The numerical example for discrete probability distribution that we're going to use is problem number 5.8. Here, you plan to invest $1,000 in corporate bond fund or in a common stock fund. So you have bond fund and stock fund. Okay. The following table represents the annual return, okay, under several conditions, the economic conditions. These are all the possibilities. Okay, you have listed all the possibilities. You have not missed anything. And for each of the economic condition, we have a probability associated with that. And make sure that you add these probabilities and that sum is equal to 1, and that is required, because otherwise this is not a complete valid probability distribution. So make sure that these probabilities sum to 1, and then we're going to compute the expected return, standard deviation. Then would you invest in the corporate fund or the common stock fund? We want to explain that. And if you choose to invest the common stock fund, what do you think about the possibility of losing everything? Because if you invest in common stock fund, if there is extreme recession, then you lose everything. Okay, so let's go to Excel. Okay, so this is the given information from problem number 5.8, and we're going to compute the expected value of X. Okay, that's bond fund, let's call that X, and stock fund, we'll call that Y, and the expected value of Y, and the variance of X and variance of Y. So these are the possible outcomes of the future economic conditions, and these are the probabilities. Okay. Now we sum these probabilities here itself, okay, and it is 1. So this is a valid probability distribution. Now first let's look at the bond fund. So if we copy these, we're going to get all these X values here. So these are the outcomes. So if you multiply X, so that's the outcome if you invest in bond, and multiply by the probability. So X times probability of X. Okay. And then if you sum that, and you get the expected value of X, which is also mu sub X. Now when you have a range of values that are multiplied by another set of range of values and summed, so it is a sum of product of pairs of values, you can use another function called sum product directly, and you can skip this step. So here are the various outcomes of the bonds, comma, the corresponding probabilities, and so both ranges must be of the same size, otherwise it won't work. Then you get the sum of the products. So the same thing. Now that's the expected value of X. Now if you take each X value outcome minus the expected value of X. Now that must be absolute referenced. And then you square that. Now you take that squared deviation, multiply by the corresponding probability. Copy that. Then if you sum, what you get is the variance of X. You take a square root of that. Take a square root of that G25, so you get the standard deviation. Now if you take the standard deviation and divide by the mean, you get the coefficient of variation. We talked about coefficient of variation way back in chapter 3. So the variability in the bond fund amounts to 86.4. Otherwise this would be a kind of a risk measurement. Now we repeat this computation for stock fund. Now for stock fund, probability of each outcome, and the outcome stock fund return is here from column E. Now you can copy these two. Okay, now you multiply y with the corresponding probability. Okay. Now you sum that, you get the expected value of y. And we can get this from some product as well. Some product of the outcomes, monetary outcomes with the corresponding probability. So of course you're going to get the same value for the expected value. And then we have y minus the mean of y, that should be absolute referenced. Square that. And then the squared deviation multiplied by the probability. Okay, now copy that. The sum of that is our variance, and square root of that is the standard deviation. And if you take the standard deviation and divide by the mean, you get coefficient of variation. And you see the stock fund coefficient of variation is really high. Obviously, there is much more risk involved in the stock fund. So expected return of corporate bond fund, standard deviation of corporate bond fund. Okay, we've already done that. Would you invest in corporate bond fund or common stock fund? So we have calculated both information. Now the question is, in which of the two funds you'll invest, of course, is going to depend upon your ability to take risk, your risk averseness. If you're risk averse, of course, you're going to go with the bond fund. If you are willing to take risk, you would go with this. Now, answer to question D, the possibility that you may lose everything, that probability is really very, very small. Even though the risk is there, but the probability of that happening is really, really minuscule. So that may be overlooked. If you are willing to take that small risk, still there is a risk. So you have to be willing to, you have the ability to absorb that risk.